Anyone's begin? I didn't hear.
Yeah, sorry, Ming. I was typing furiously away trying to figure out why the uploads were not working.
Okay, good. Yeah, I just checked.
But I think we are ready to go. So let me share the slides again. And we are at time, and let me make sure Brendan is here. All right, so welcome to our last session and last day of IETF. Thank you to all of those who I realize it's either super early or very late for you for sticking it out and joining in on the discussion. You are attending the Trusted Execution Environment and Provisioning Working Group. I'm just going to try and go through this quickly. By now, hopefully you're all familiar with the note well, so I don't think I need to go through this one either. Similarly with the meeting tips, I'm just going to bypass that and get to our agenda bashing. So first off, I want to have a huge thanks and shout out to Hannes and to Ming for signing up to help take notes. That'll make my life a lot easier. I didn't know how to allocate the time, Dave and Brendan, but given that we have a 2-hour block and we only have a couple more issues to go on the protocol, I figured it was okay to just leave it as this, but I figured I'd give you guys the chance to bash the agenda.
That looks great to me.
Okay. Brendan promises the manifest examples will not take an hour. We appreciate that. And I didn't, I uploaded both decks, Brendan. You gave me both for the manifest and the examples. So I've uploaded both and ready for you to present when your time comes up. So if everybody's okay with the agenda, we can move forward with the TEEP protocol issues. Dave, you want me to share again?
I'm okay either way, whichever you prefer.
It matters not to me.
Okay, why don't you do it? We're on slide 14.
Yep.
Okay,
all right.
So in case you were missed the session yesterday, I will reintroduce this slide here and we can continue the discussion that we were in the middle of when we ran out of time yesterday. And so as a reminder, section 4.2 of the TEEP protocol spec says that the TAM can query the TEEP agent, that's what runs on the device, to see if it supports OCSP. Via the capability discovery exchange as described above, but that it does not actually describe any capability discovery exchange. There's no way to query it. There's no way to report it. And so the question is, what should we do about that? And so during the session yesterday, there was some discussion. I think Russ had an argument that there might be things that you'd want to use other than OCSP in some cases. And so maybe we do need a negotiation mechanism. If we do have a negotiation mechanism, we have precedents for like when we negotiate cipher suites and freshness mechanisms. And so that would be option 2 on there. And we kind of called time in the middle of this discussion. And so let's restart that same discussion. Is Russ with us? Not at the moment. All right. So my reading of the discussion so far is that I heard arguments. I heard originally 1 or 2 people argued for option 1, but then we had people that got in line that argued for option 2, and I did not hear any responses to that. And so I think the consensus is leaning towards option number 2, but I'm not sure yet. So let's restart that. So for comparison, when we negotiate cipher suites and freshness mechanisms, we have sections in the document that says, here's an IANA registry, here's how you can add another one that you might want to negotiate, and then here's how to have a bit that's the data item requested set of bits. So we allocated a bit in there for the other ones. And then we added a field in the query response to be able to report the list of things that you have. And so option number 2 would basically be repeating that, of which maybe OCSP might be the only thing in the list for right now. Maybe there's something else that somebody wants to argue. I think Russ mentioned CMS or something like that. And so at this point, I'd like to open this up for discussion to say, should we go with option number 2? And if we go with option number 2, what should be in the initial list of possibilities? And is there anything that is mandatory to implement, or is there nothing that is mandatory to implement? So that's the set of questions that we like to restart discussion on here.
So Ben raised the discussion that we had yesterday for option number 3 as well, Dave. Because
remind me what that was.
Yeah, there's no negotiation. OCSP is mandatory.
Oh,
Right, that
okay,
option
right.
3. Yeah, option 3 is making that mandatory.
Yeah. Okay. Thank you for the reminder. Okay. Yep. Those are the 3 possibilities. So again, yesterday I heard Russ, which I interpreted as an argument for option 2, and then we called time, and so people didn't have a chance to respond. So.
Okay, Hannes, you're in the queue.
Dave, the number 2, does that mean is a sort of like the negotiation? Is it sort of the DAM asking, do you support OCSP? Is that what you mean by that option 2?
So feel free to propose a different meaning of option 2, but the meaning of option 2 that would be the most consistent with the negotiation of cipher suites and negotiation of freshness mechanisms is that there is some implied default, which gets to the mandatory to implement question. The implied default might be nothing or might be OCSP, depending on what we would decide. But there's some default that if you want to know specifically, then what the TAM does is it sets the data item requested field to set the bit that says, please tell me what you support as far as OCSP or equivalents. Okay, and then in the query response, there would be an array of 0 or more entries that the device, meaning the TEEP agent, would say, and here's the set of things that I support. So there would be a value for OCSP, and if CMS or whatever else was an alternative, there would be a value for that. And the device could say which of those 0 or more of those possibilities that is in this registry it supports. And then the TAM could then use that for doing operations like update or whatever, constructing those messages.
Okay, and then a follow-up question, like let's say this device supports OCSP for whatever reason, where would that come into the picture? Because we have the COSI mechanism, and presumably the DAM or the DAM, when it signs the message and sends it over to the device.
That's the next slide. There's a separate issue that's what do you do with OCSP that is the next slide, which is right now we factor them 2 issues. Can you discover can you discover the capability, and then what is the capability used for? Both of those are problems in the document right now.
Okay, so. Separate issue. Okay, good.
So hold that question till the next slide, because I see others in queue.
So I guess maybe we should have done the 2 questions in the opposite order, because if there's nothing to before, then it doesn't matter if we negotiate. But I came to the mic line just to say that sort of in the general, from a high level perspective, if you have a PKI system going on, you pretty much need some sort of mechanism for conveying revocation information, unless your credentials are so short-lived that you can get essentially revocation just by not renewing the credentials and letting it expire. And so the mechanism that Russ had mentioned was OCSP stapling, I believe, which is you send the non-revocation message alongside your actual application message, or you can have the recipient of the signed message go off and query the OCSP status or you can have the recipient of the message go off and query a revocation list. And like, I don't have a particularly strong preference about what exactly we do here, but I think it's pretty likely that if we actually, pending the outcome of the next thing, if we do have some protocol interaction where we might need revocation information, we need some way to get that revocation information. And OCSP stapling might well be the best way to do that.
Ming?
I just want to indicate that in version 1 of this protocol, we actually just by default we send in OCSP stapling, right? So in a tab request, it send OCSP stapling. Data is put in there. We do not negotiate the cipher suite or what user sign in, but we send over, assume the device TEEP agent process. If you cannot, then response may say I don't support it. So now this one, this slide is more is a proposed new requirements about a negotiation piece or the discovery piece, compared discovery. I think this is new. I just want to go back to whether we can just fall back and say, time is always can get the OCSP stapling, right? I think that's a basic functionality. It can always send the data over saying I'm not revoked, right? So as a proof, and leave that to TEEP agent to process, right? It have a policy that says, okay, it's a time server I could trust based on this OCSP stapling data. So
I don't see Russ here, but the argument, as I recall, that Russ was making yesterday, if I understood it right, is if you have a constrained device, if OCSP stapling is not mandatory to implement on the TEEP agent side, then sending it large amounts of data might be difficult for constrained nodes as far as power and bandwidth goes. And so I thought he was arguing that there might be more constrained-friendly solutions than OCSP stapling. But I'm not sure I got his argument right, but that's how I interpret it. So I'm wondering if we should cover the next slide first and then return to this question.
Okay.
Yeah, maybe we go to the next slide, but I want to come back to the point that Ben mentioned, that we need to have a revocation mechanism, and OCSP may be the best choice because it's also defined in TLS. I want to come back to that.
Okay, so I'm expecting you three to stay in queue or whatever, or come back in the queue, your preference. This one didn't fit on one slide, so it's actually split into 2 slides. So issue 148 is, what would you do with OCSP? Okay, so in section 4.2, it actually mentions OCSP data. Okay, you can see section 4 with the query request. The TAM provides OCSP data so that the TEEP agent can validate the status of the cert chain without making its own external OCSP service call, right? And similarly, in security considerations, the TEEP agent should, meaning it's already optional, but it's a should, use the OCSP information to verify the validity of the certificate as well as intermediate certificates. Okay, so that's what those 2 sections talk about, it being a should to implement, and that the TAM should be providing it, right? That's what the document says right now, okay? However, section 4.1.2, which is a section on what you do to validate a TEEP message, does not mention anything about OCSP. So it doesn't say how you do it. There's a set of steps that's there. It does say follow the steps in 8152 for validating a COSI sign object, but of course, 8152 does not contain any mention of OCSP itself. Okay, so that's half of it. So let's advance to the next part, the next slide. Still on the same issue here. All right, so if you compare what the document has right now from the old OTRP spec, okay, what are the old OTRP spec before we did the TEEP protocol? What did it do? Okay. It had, in the equivalent of the validating the OTRP message, right, the validating the TEEP message, it had text like the following. This is a quote from the old OTRP spec that we had. Validate that the request TAM certificate is chained to a trusted CA that the TE embeds as a trust anchor. Cache the stapling data and certificate replication check status for other subsequent requests. And can use its own clock time for the OCSP stapling data validation, right? So it had explicit steps in here when receiving a message of how you validate the TEEP message by checking for certificate revocation. The current document never says to check for certificate revocation, right? It says the TAM should send it so the TEEP agent could, and the TEEP agent is it should implement OCSP, but it doesn't say how. So this is an equivalent text that OTRP had. So the question in issue 148 is, should we add some similar text like what's on the screen here into the TEEP protocol spec? Or is there some other document that already does, because 8152 doesn't, that you could reference? Or should we say something else or say nothing, right? Those are kind of the possibilities here. Because right now we don't say what you'd ever do. It doesn't actually say do a certificate revocation check. And this is the text that was in OTRP that did that. All right, Hannes.
So if we assume that OCSP stapling or OCSP in general is a good solution, then I'm a little bit worried about sort of the interplay with COSI, because as you correctly said on a previous slide, it actually doesn't talk about how that works. And the encoding is also different. That maybe may add a lot more code, defeating a little bit the point of the COSI encode or the CBOY encoding. Additionally,
right. Obviously, the old OTR spec did not use COSE, right? COSE was what we changed to when doing TEEP, right?
Right. And the next point is the COSI spec not only, actually preferentially doesn't use X509 certificates in the first place. That was only added later as a sort of an extension. I think there's still work on that is ongoing. So that you may have other encodings. Is it an RFC now?
It's almost ready to go to the RFC editor, but it's not quite.
Mm-hmm. But
a second. So Ben, does that mean that there is a document about revocation checks with COSE that is potentially referenceable? Is that what I heard?
No, only an X5, the possibility to carry an X509 certificate in COSE.
Okay. Well, so it does actually. So I have the. Oh no, never mind. I'm not looking at the draft. I thought I was.
Okay. But the other thing is, and that may have then other consequences for the document, is COSI also allows to use non-X509 encodings of keys, and we would I don't understand how OCSP would actually help in supporting those. I never looked at that, and maybe you guys know. But that aside, I'm wondering whether OCSP is even the good solution to begin with, because even in TLS, I doubt that it's a successful solution, because while it's specified, it's not actually used as widely as you may think. In fact, MPI TLS doesn't even implement OCSP because there was never the demand for this on any constrained device. And the reason is also why it's not used in many places is because you can bypass the whole story by an software update mechanism. And that's what the browsers do as well. They update certificates, and because ultimately if you find out that important certificates have been revoked or are otherwise compromised, you need to do something about it. So I'm curious on what the story here is.
Yeah, and of course the TEEP protocol is an update protocol, right? So that's a valid point. Ming, do you ever comment on that?
I think Hannes raised a good point, right? I would say still a lot of cases we use certificate, and with certificate is a relatively long-lived, right? There's a revocation, so if it is revoked, shouldn't the client to check? So if we just ignore it, that just broken the ecosystem, right? I think once you have certificate used, at that case, it should have some revocation check. If a public key used, will imply implicitly that a key is valid, right? You have nowhere to revoke and check whether it's revoked. You just trust it, right? But even certificate-wise used is for that purpose, right? Revocation. Now come back and say OCSP stapling versus OSSP. I think as I would go back and say, do we support a revocation check, right? You can use OCSP stapling as one way, efficient way, because for devices, it's not efficient to go out to OCSP query directly. And as an analogy with a browser, yes, and a chromosome, they have as a frequent update. They could load CIL, this interest set, right, a subset to the browsers to shortcut it, but they still do OCSP. As to my understanding, they do try to do OCSP, but it does file open with a file close, and they use that CIL delta, so the data as a stopgap, right? Stopgap to enhance that revocation check. So the purpose is still does revocation check. It's just how part. So I think as a requirement here, I come back and say we should do revocation check by client. We could discuss about how. I think the one for this, right? If it cannot, we should define a policy. If the client cannot do, and what it should do, that come back to the last slide, negotiation, right? And the discovery. That's just my comment from this one. So as I could say, for my comment, that's definitely your question is this one. If certificate use should be mentioned, I say yes. I think this should be mentioned in document. Explicit is what do we do with a revocation check.
Okay, Ben?
Right. So I think Hannah's covered a lot of the key points. Namely that we switched to using Cozy, and Cozy by default assumes you're not using certificates. And so Dave, you had asked the question, would OCSP make sense with non-X509 certificates? And the answer is probably not really. So I guess the answer here is that since we're using Cozy, we probably don't need to talk about OCSP quite so directly. I think the sense in Cozy tends to be that the key management is left up to the application. You might use just hard-coded keys that are in your software, and you do revocation and key update by software update. There's a little bit of discussion in the chat to that effect as well. What the browsers are doing by handling certificate revocations in the software update is sort of analogous to a CRL, but again, it's managing your trust anchors in the software itself and hard coding the keys, which is very analogous to what Cozy does. So because Cozy leaves most of the key management up to the application, we, to some extent, will also need to do so, but it's probably still worth mentioning that there is a need for revocation, as Ming has said.
So we actually had an issue in the architecture document that resulted in text changes that are in there now. That the issue was filed when the question was asked is, could you use the TEEP protocol for managing your trust anchor store? And the answer is yes. And so there's discussion in the architecture document about that right now, right? You can treat your trust anchor store as just another component that could be updated via the TEEP protocol if you wanted to do it that way. And so there's nothing special that you have to do with the protocol. It's just another set of content that you're installing across, the secure TEEP protocol. So one approach is what I'm hearing is we could remove all mention of OCSP and stapling data from this document. Okay. I think I heard Ming and Ben, you were, I think, both saying that you should have not how, but just a state that you could, if there, in some cases, there may be a need to do a revocation check of some sort, but not say anything about how, if I understood your suggestion correctly. And the document should not mention OCSP anywhere in it. And if you did that, then to just respond to Ming's point, then maybe we don't put any negotiation mechanism into here and we just leave it out of scope and say, well, you can use the TEEP protocol to update your trust anchor store. And if you want to revoke something, that's what you do.
That seems to accurately summarize my sentiments. Thanks.
Ming, is that consistent with what you were arguing?
Yes.
Because I think that would then resolve both of the past two issues because there would be no negotiation mechanism. We would remove all mention of OCSP. And it sounds like, Ming, you would want us to add a sentence very similar. Well, we should, like the first sub-bullet, that one still applies because that one still doesn't mention OCSP. The second bullet there mentions OCSP stapling data. Yeah. And it sounds like you'd want that one to be a more generically worded thing that says, do a revocation check if applicable, that kind of thing.
Yeah.
Okay.
Yeah. So the first bullet point does still talk about certificates, and
you're right.
Really a good fit for Cozy.
Sure. I think we have some text someplace that is not specific to certificate that might be in the architecture document that we could steal and use the same wording.
That sounds good.
Because if you were just using straight, public keys, public key cryptography and with no certificates, then you can just say, validate that the request TAM public key is in the trust, it is a trusted, is in the trust anchor store, right? Which matches the little table we had. So we can figure out what the appropriate wording is, but I think that gives us appropriate guidance as editors. So
yeah, that's right.
Okay.
Yeah.
All right. Unless there's any other comments on this one, I see the queue is empty. I see Daniel. I agree with this way of doing. I don't know if that's in response to the chat but seems like we can go on to the next issue now, Nancy. Okay, so I need a CBOR expert to tell me. Section 411 talks about, says take the COSE sign object and prepend it with the TEEP CBOR tag. And section 2412 says remove the TEEP CBOR tag. Okay. And in fact, 10.4 registers a new CBOR tag whose data item is TEEP message. Now, of course, there's no cross references between those two sections, but if you flip back and forth, you can probably conclude that 411 and 412 are actually referring to 10.4. But the use is unclear to implementers, right? There's no cross references. There's no use in any example or CDAL in the document. And so the reader wonders, how does this relate to the COSE sign one tagged thing? And so we need a CBOR expert to say what the document should actually say here and what the example should actually show. So, Hannes?
Yeah, I wanted to, I only now saw the chat. I wanted to come back to the previous issue and respond to one comment from David Brown.
Okay.
If that's okay. He was saying that the issue is that the MCU boot is generally mutable. And of course, like that would obviously be a showstopper for the update. On the other hand, if you, I think there are also ways to deal with this, like having a second stage bootloader but clearly, and that's probably something that we need to write up or describe better. The issue is that at some point in time, the root of trust, there is various different parts of the root of trust, hardware, software, and also configuration data like trust anchors. And some keys you will not be able to update. And that's also puts a limit on any revocation mechanism, whatever technique is being used. Because even if you find out that it doesn't, there's something wrong, you can't change it. So like in our case, what we do is we have a second stage bootloader, even a third stage bootloader, depending on what system it is. So you can still update everything except for the first one, which is part of the root of trust. So I think we can get around this to a certain extent by appropriate wording, but it's obviously an important point, and that's why I copied it into the meeting minutes so that we don't forget it.
Yeah, I saw the chat that there's two ways of doing it depending on your implementation. David's point was, even if it's immutable, you might be able to pass a CRL as the mutable configuration and just be able to use TEEP to update the CRL. I think that was David's point. And then your point is, yeah, you could do is two-stage bootloaders, and the second one is mutable, and you can do stuff there. So yeah, it depends on your implementation, right? Those are, I agree with both of those. So, okay. So back to 147. Actually, Ben is in queue. Are you on past issue or 147?
Ben, you're in the queue.
I was up for 147 in the absence of some other COSE expert. So in general, or CBOR expert, really. So in general for CBOR, you can have a bunch of the different data structures like the integer, map, string, text string, whatever. And sometimes you might want to preface them with what's called a CBOR tag to give some extra information about what the contents or the semantics of the following thing is. And so what we're doing in 10.4 is to allocate a CBOR tag that says there's going to be some stuff after this, and that stuff is definitely related to TEEP. And now the usage of these CBOR tags is generally going to be optional. It's possible to write your application using CBOR in a way such that the nature of the content is just always known based on some external context. And so in that case, you don't actually need to use the CBOR tag, but it's pretty conventional to define or allocate the CBOR tag for situations when there's not that extra context and you do need a little bit of a hint. And so what I'm reading this quote about 4.1.1 is saying is that you're going to end up with a message that has this TEEP message tag, and then right after it, you're going to have the cozy sign1 tag, and then you're actually going to have the cozy object with the signature and the content. And so the reason I'm thinking that is that in 4.1.2, we say that the validation step is going to remove the TEEP message tag and then verify that there's a cozy CBOR tag after it. And so that's sort of implicitly putting a requirement that there is the cozy CBOR tag following it. And that's what directly maps up to the cozy sign1 tagged at the bottom that you have. So the Octothorpe 6.18 cozy sign1 is the diagnostic notation for the tag that corresponds to the cozy CBOR tag. And so does that help?
Maybe. But you'll notice that 4.1.1 and 4.1.2 is still saying all of that goes inside of a TEEP session. So you've got a context that says that it is TEEP already, I think. And so is there any value add that a TEEP CBOR tag actually provides by putting it into TEEP protocol? Because normally you're not trying to demultiplex to say, this one is TEEP versus something else, right? We have other mechanisms to do that. For the TEEP transport protocol does that.
So I'm not super familiar with the sort of surrounding context of the document in which this appears, but what you described definitely sounds like we don't actually need the CBOR tag for TEEP message.
Okay. I guess my preference, having started oh, I'm sorry, go ahead.
Yeah, I was going to say, Hannes just put in the chat that he also doesn't think the tag adds value.
Yeah, I saw that. Yeah.
Okay.
So that's my conclusion as well, is it does not add value unless somebody comes in and says, no, you need it for the following reason, right? And it's easier to just remove these sentences from 4.1.1 and 4.1.2 and all of 10.4, rather than trying to add examples or whatever as to that actually start to show it. I have not implemented this yet because I couldn't figure out how to implement that based on this text that's right here. And I suspect that Akira and Asobe-san and Hannes have not either in their implementations, but I'd love to hear otherwise. So,
yeah, I think the conclusion from this live discussion is that we can just remove the mention of the tags. And it's probably worth trying to sync up with like Karsten or somebody and just confirm my recollection, because I'm not really a CBOR expert. But to confirm that the use of a CBOR tag is optional.
Yeah, and you'll see that today 4.1.1 references cozy sign1. It does not reference cozy sign1 tagged, right? And so again, my assumption is going to be there's no reason to reference cozy sign1 tagged, right? You just put in cozy sign1 directly.
Right, that would be the consistent outcome.
Okay, and Hana says it matches his memory of CBOR. Okay. So we'll take that as the proposed direction for the next spec, next rev of the spec. And if we get it wrong, then I'm sure Karsten or somebody else will tell us.
Brendan's in the queue.
The only reason you would use a tag on the cozy sign1 is if it were acceptable to use a cozy sign as well, and you needed a way to disambiguate that. Likewise, if you wanted a variant where you had cozy mac or cozy mac 0, you would also need to have a tag so that you could identify exactly which authentication object you were using.
Okay, that makes sense. I think the 4.1.1 and 4.1.2 text originally came from Hannes, who did the first rev of the TEEP one. Did you have anything else in mind? I think currently it only supports sign 1. Is there any reason, Hannes, that you know of to support any other alternatives that Brendan mentioned?
Yeah, initially, and that's why I used that tagged version of the cozy sign one, was because we didn't, we allowed, I think, also other options.
So the clarification that you would probably want here is that cozy sign is what you need if you're ever going to have multiple signers. So if you ever need threshold signatures or 2 sign-offs to be able to do something, then you're not going to get all the way there with Cozy Sign 1.
Okay, so I can see 3 different ways that we could go. We could say we just embed Cozy Sign 1 directly. The next one is we could create a TEEP tag, which is basically what 10.4 is doing right now. That gives us that flexibility if we need to do something else in the future. And then I guess the third possibility is we could just embed Cozy Sign 1 tagged in there and use the 6.18 as the way to disambiguate. Those would be 3 possible approaches we could take. So far, I heard people arguing for the just remove it and don't provide that flexibility, but that was before you jumped in to ask about that. So I think it's worth re-asking the question now is, do people think we should have a tag, whether it's a TEEP-specific one or the generic Cozy Sign 1 tagged value to as a discriminator in the future? Sounds to me like people don't care.
Well, I would remove the flexibility. I think it adds the Cozy sign is not appropriate for what we do, and adding our own sort of shim layer doesn't make a sense. That doesn't make sense either.
Okay. So unless somebody argues that we need that flexibility, thank you, Brandon, for the explanation. And so I take it as that has not changed the proposed resolution, which is to remove the tag and just use Cozy Sign 1 directly as the. So unless somebody has a compelling reason, then we'll do that in the next rev of the document, and we'll see if people like that. So, okay, I don't see anybody in queue, and so it's okay. Next, IANA registration policy. So the spec currently has 2 IANA registries in there: the Cipher Suite registry and the Freshness Mechanism registry. And so in the IANA considerations, it says, hey, we'd like these 2 new registries, but it doesn't actually say what the registration policy is. 8126, which is the RFC that says what you're supposed to put in IANA considerations, says that whenever you create a new registry, you have to say what the registration policy is, and it gives you us a menu to pick from, okay? And so we have to pick one of those for each of those 2 registries and actually say what the expectations for IANA is, okay? So for example, for Cipher Suites and Freshness Mechanisms, is there any reason to allow private or experimental use, or is it just straight, you get a red value in the registry and the registry is simple? Within the registry, is it first come, first serve, expert review, and so on? And so when Russ asked this question about do we allow Cipher Suites without confidentiality in the future, right? He said, and guidance to an expert, right? Which we would assume that it's something like expert review, but we never actually asked whether it was expert review or something else, right? And so this is the time for us to actually make that decision here. And then finally, what information should a requester, if I want to add a new Cipher Suite, what do they need to supply in a form or free form email or whatever to say, I have a new Cipher Suite request. What do I need to provide to ask for it? Okay. So we need to fill that into our IANA consideration section before we're done. So any thoughts on policies or any of the bottom 3 questions there? Yeah, Hannes?
Go ahead, Hannes.
In general, I'm more in favor of having to make it easier for authors and specification authors to register new Cipher Suites or anything. So in that sense, I would lean more to maybe specification required. I don't have an opinion about the experimental use or.
No opinion. The least workers did not mention anything about use for private or experimental use that you got to get an allocated value. Now, whether that would cause problems for implementers, I have no idea, but that's kind of my question. But if nobody asked for it, then we'll naturally leave that out. But since most registries don't, but some do, so. Okay, so I hear you arguing for a specification required. Anybody else have an opinion on that one? Otherwise, we'll pick something, put it in the document, and see. But if people have a preference, we'll pick the one that the working group directs. So, okay. No opinions? Okay. Good to know. It means nobody has a strong opinion and just about anything is okay. There's sounds like there's a suggestion for specification required and nobody arguing for anything else. So let's go on to the next. Oh, anything else in chat here? Seems reasonable, looks good. Okay, thanks guys. Daniel, somebody sounds great. All right, and so with that, so I've gone through most of the issues that were filed during the hackathon. And then there's one GitHub issue that we discussed last time where we said there was a GitHub issue filed that had to do with what's the TEEP profile for suit. And last IETF, we talked about a desire for 4 things being added into the document. And so I'm just looking at the minutes, the bullets from the minutes from last IETF, which was there was suggestions for 2 sample suit manifests for specific cases and 2 sample suit reports for the success and failure cases. And so Brendan took on the task of working on that particular issue. And so I'm now going to hand it over to Brendan to talk about the suit manifest examples and the suit report examples that are proposed for adding into the TEEP protocol document. So.
Brendan, do you want me to share? Or you want to share?
I don't mind either way. You're
I'll
sharing.
let you
Excellent.
share because I'm not sure which of the 2.
Oh, okay.
So I did
Never
upload
let
the
the-
manifest and the suit report.
Never let
So
the
you-
chairs decide.
Yeah.
Brandon.
Manifest first, because the suit reports are talking about the response or the output of what happens when you process the manifest. You got to talk about the manifest to understand the suit reports.
I hope this is the right one. Yes, there we go. Okay, so we'll go through a couple of assumptions that we made for this example. So the idea is that it's going to be using Opti on trusted firmware A on trust zone. It'll use the TEE secure storage in RPMB. The TA is going to be saved to a file, which is the unpronounceable UUID there in RPMB. And the TA developer doesn't want to use a second TAM. They're just going to use an HTTPS server to supply the personalization data. Now, the TAM will deliver unique personalization data manifest to each TA instance, and each personalization data manifest will have a dependency on the TA manifest. The personalization data manifest and the TA binary manifest are going to be delivered in a TEEP update message, and the personalization data will be delivered via an HTTPS URI. So I'll go through this step by step. Now, I have not put a signature on the manifest, the personalization data manifest, but we can have a look at that when we get to the TA manifest. So the authentication wrapper in this case is a suit digest, which is just that element on the right-hand side. So an algorithm identifier and the digest bytes. I've skipped over the manifest version and the sequence number. Next, there's a dependency, and you can see here the dependency is declared as just a digest. And that digest, to be clear, will match the TA manifest digest. Next, we get to the components that are defined. So one component is defined in this manifest, and that component is a path, essentially. Now, the first element is opt-D. The second one was supposed to be RPMB. Not exactly sure what happened there. There may be a bug in the suit tool. I'll have to take a look at that. And then the third element in the path is config.json, and that's the name of the file. Next, we've got the common or setup section. Now, what this does is it specifies a component index. Now, that references back to the list of components we just saw. It then declares that the declares some parameters for that particular component, in this case, the vendor ID and class ID. And there's an explanation later on exactly what those UUIDs mean. then an image digest. So that's the digest of config.json in this case. And there should be a size in there, and I'm not sure why there isn't. Then there's a condition vendor identifier and condition class identifier. I think I must have missed copying something into the slides. There really is normally an image size. So what these conditions do is they compare the declared vendor ID and the declared class ID against the ones that are stored in the device or in the TEE. Next, there's a dependency resolution step. What this does is it goes and gets the dependency manifest. Now, in this case, that's probably sorry, that's not probably, that is the TA manifest. So here it declares the URI that it's going to fetch from, and the next part after that is that it does a fetch, and then it checks whether the manifest matches the digest that it already has from the original manifest dependency declaration. Next, it goes through an installation process. So for installation, it first goes through and says where it's going to find the config.json. Then it goes and it installs its dependency. Now, yes, Dave, I see the chat. I will talk about that when I actually get to the TA manifest. That's coming up. But for this part, it's fetching the config.json, or it's declaring the config.json. So you'll note that it says it does a process dependency before it does any fetching. So that would be an opportunity to do an attestation following that process dependency. Now, there isn't currently a command in suit for doing an attestation, for instructing the TEE when the right time to attest is. And that is an interesting question. Whether that would be appropriate in this case, I'm not sure. I think that I need feedback from the TEEP working group on whether having a way to instruct the system when to do an attestation is important or not. But continuing on, once the dependency has been processed, and we'll come to what that means in a moment, the next thing to do will be to fetch the component that's identified here, which is the config.json, and then check its digest. So what process dependency does in this case is it goes and runs the install section for the dependency manifest. So we'll come to the dependency, which is the TA, in just a moment once we've finished running through the personalization manifest. So I've put validate and run on the same slide. Validate just checks that the component that's identified here is correct. So that revalidates config.json, and run just runs the TA. Well, I mean, it runs the process dependency, and the TA manifest presumably runs the TA, and we'll see that in a moment as well. Now, this is you can think of the manifest as divided into two sort of notional sections. There's the part that you use to install software, and then there's the part that you use to securely invoke software. Now, whether a TEEP manifest would include these two sections is entirely up to an implementer. They might have their own way of doing secure invocation. They might not need this, but this part handles that stage of the lifecycle. So then there's a text section which gives you a little bit of detail on exactly what you're seeing in the manifest. So here the different sections in text are identified by component. There is some additional text that can be placed into the manifest that doesn't just have the component identifiers, but the idea here was that it would show the model name and vendor domain for each of the components, And this shows where the vendor ID and class ID came from. So the vendor domain the vendor ID is a UUID type 5, which is computed from the vendor domain, and the class ID is a UUID type 5, which is computed from the model name. Next, I'm into the TA manifest. So the actual authentication version would look like this. Sorry, the actual signed version would look like this. So the first element in the authentication list is a suit digest, followed by any number of COSI sign 1, COSI MAC, or COSI MAC 0 objects. So here you have the you see the same digest as before. So not a different digest, the digest for this manifest, but again, a digest, and then a signature that follows it. And in this case, it's ES256. I have removed the actual signature bytes for the sake of brevity, but that is the overall structure. And to be clear, the signature is run in detached mode, and it authenticates the digest. And the reason for this is that that digest is the digest of the actual manifest element in the suit envelope. And if there is more than one signature algorithm in use, so more than one COSI sign, having the digest placed inside the signature, which was the original encoding, would increase the size by 1 digest size for every signature that's added. So that's the reason that it's separated out like this. Next, again, there's this common section which declares the components, and there's only one component in this case. And again, there seems to be some kind of encoding error. RPMB didn't come out as RPMB, it came out as something else. And then we have a UUID, but that's been re-encoded into binary and followed by TA. Right, I should address Ben's comment. Yes, you end up with a repeated digest, but it's not strictly a repeated digest. And the reason being that the algorithm ID is actually embedded in the digest that gets digested. So it's not quite the same as just SHA-256ing a SHA-256 output. Then there's, again, this common sequence. The common sequence defines the parameters that are used for this particular part of the, well, the TA, in fact. So there's the vendor ID and the class ID, and again, the image digest and the algorithm ID, sorry, the image digest and the image size. In this case, the size is actually there. I think I know why the size disappeared. I think it's because I didn't have a config.json to hand it, and so it just didn't get a size. Then we have the vendor identifier and the class identifier conditions, and what those do again is to just check that for the specified component ID, they match the hardware declared or underlying software declared vendor and class identifiers, and they match up with the ones that are declared in the manifest. Next, there's an installation step. Now, here is where the earlier comment from Dave comes up. Here it defines the URI that you might expect to find or where you might expect to find the TA, and then does a fetch. Now, the expectation here is that the fetch will be done by checking a local store first in all cases. So if you have a local storage for something that might contain the TA, you really should look there before you go out and fetch it from a remote URI. And since the the digest of the TA is already declared at this point, doing a lookup off of that digest is probably the right way to handle this. Next, there's again the validate and run, and you see here that validate is simply a
comment
image
before you
match.
go on, if I may. I jumped in queue, so. So my comment earlier was different from this one. I agree with everything you said, but my comment earlier about was the case where you have one manifest, in which case the personalization data manifest that depends on another manifest, the TA manifest. My comment earlier was you don't have to go off and fetch the TA manifest from someplace because you've already got that. So
if you already have it, sure.
There's two different concepts of fetch, right? Go and fetch the manifest and then go and fetch the binary. And so in theory, both of them are already cached locally. But my comment earlier was you've already got the TA manifest locally because that came in the same message as the personalization data manifest. And separately, your binary here might have been cached because, say, it was bundled with the rich app, for example. So both are true. So
yeah, one of the overriding design principles behind the suit manifest is that many of these operations are actually just copies of each other, but with different parameters. So it parameterizes all of the common operations so that you don't have to have special cases for fetching a manifest versus fetching a payload. They're the same thing, so they're done the same way.
Hannes, you're in the queue.
Brendan, I was wondering, there was the requirement that that the personalization data is unique for the instance. That's something you said on the first slide, and the DA binary that you have on this slide obviously is it's the same for all the devices or for the entire class of devices. But how do you make sure that the personalization data is unique for each instance? That's something I missed somehow.
Yes, that's because it's not in here. So,
Intentionally?
Sorry?
I was being flippant, whether it was intentional or not. Yeah.
No, intentionally, because there's only so much I can fit in these slides, and I promised you that I'd get it in under an hour. So the point here is that the way that you ensure in this case that only the correct recipient receives a given set of personalization data is through TLS client authentication, and that is something that would come up in it won't let me go back far enough. Here we go. In our initial assumptions, right? That the personalization data is delivered via an HTTPS URI, and that it's not using a second TAM, just an HTTPS server. So if you want to ensure that there is authentication of your clients and that only the correctly authenticated client receives the correct data, then HTTPS client authentication is probably the answer. We did want to do another example where the TA developer used encryption to secure the personalization data. The issue that we had with that is that it depends on the development of the suit firmware encryption draft, which is still in draft. We haven't moved it along far enough that we are at anywhere near consensus. So that, I think, is why we decided that we would stay away from that particular part of the discussion just yet. So when you flippantly asked, intentionally, the answer is, in fact, yes.
Well, that makes total sense. The HTTPS approach is perfectly fine.
All right, where were we? Right, so validate and run are quite trivial. You check that the image matches, and then you run it. And we've got a little bit of text in this one as well. Similar idea. It's got the vendor domain and the model name, and those are indexed by the component ID. And that is all there is to the example. If there are any other questions, happy to take them.
Dave?
Yeah, so for anybody who wasn't in the suit session a couple hours ago, there was this discussion for everybody else that we had about taking the suit manifest document and moving a couple of parts of it outside of the core document into extensions. And so my question is, this particular example, out of the things that we talked about moving to examples, because you just explained that the firmware encryption, which is already a separate document, we tried to pick an example that does not depend on that document, only on the core spec. But now that we're moving some other stuff, which of those things that would be moved into extensions does this depend on? Because my first glance here is I think there's only one, and it's the one that covers dependencies is going to move out to an extension. And I think that's the only one, nothing else. Is that correct?
That's correct. Yeah, the only thing in here that would be moved out of the suit core specification is dependencies.
Yeah, so we would have two normative references. Well, technically it'd be informative reference. You could get away with that because it's an example, right?
Yep.
And so one being to the suit manifest core spec and one being to the extension spec that includes dependencies. Okay, thanks.
Okay, if there aren't any more questions, I can also do the suit report examples.
Brendan, I was wondering whether, or more, Akira, whether he thinks, Akira, do you think this example is covers the case that you brought up during the hackathon?
We can't hear you, Akira.
Oh, hello?
There we go.
Yeah. We will try implementing. Yes. Yes. Sorry, my brain is a little sleepy. So it's this definitely the common section will help, and I think the difficulty we had was how to write the order inside the common section and how to express integrated dependency inside the common. So that's I think we definitely this slide is going to help for the implementation. Yes, thank you.
Excellent. There's also an example of this uploaded in the suit tool repo, which is the new home of the suit manifest generator. And I don't think there's a link in these slides, unfortunately, but I'm happy to put a link in the chat.
Brendan, it might help if you also put that link in the mail list.
Oh, sure. Yeah, that's probably the best place for it, isn't it? Yeah. Okay, I'll do that after. Right.
So Nancy, you have to approve the slide share.
I did. It's just it's thinking. Yeah.
Okay, so suit reports are pretty simple. I hope. The core idea behind a suit report is that it's supposed to tell you, if you have the manifest, exactly what's happened on your device. So if it's been completely successful, if no conditions have failed, then you get something really pretty simple. So the first part is a manifest digest, and that's just to reference exactly which manifest it's talking about. That's the root manifest, the one at the very the root of the tree. So in our example, that would have been the suit personalization data, or sorry, the TEEP personalization data manifest. And then it will provide a URI if the suit reference URI has been populated. And the idea behind the suit reference URI is to provide a canonical location to find that, even if your distribution infrastructure is different, that it will always come back to that same place. This is so that you, as a network operator, can identify exactly what this is, even if you have a munged version that's been provided by a distribution network or something like that. Now, in this example, there's an empty list of suit report records, and that's because every condition in the manifest has executed successfully, and none of them have failed, so there's nothing to report. Receiving this report would mean that everything is fine and that there's no concerns. And I should be clear that this is separate from an attestation report, that this is not the kind, the kind of data that you would find in an attestation report is completely separate from this, and that's because attestation reports report properties about your system rather than telling you how it got to be in the state it's in. Then we have an example of a failure. So in this case, something has gone wrong. So to find out what's gone wrong, we look at the report, and the rest of this is identical to the previous one, but in the suit report records, there's a little bit of a difference. So what's happened here? Well, the first element shows the manifest ID. It's an empty list. That means that it's the root manifest where something's happened. If there's a list of integers here, then that tells you how to navigate the tree of manifests according to their order in each manifest to find which one it was processing when it encountered this error. So what's happened? Well, it was in the dependency resolution section. Now this refers back to the previous manifest example that we looked at. So you see in the dependency resolution section, the 7 here is actually the 7 that is referred to by dependency resolution in suit. And then what's happened? Well, it was in offset 66. Offset 66 into this particular section takes us to the highlighted directive fetch. So that's what's gone wrong. The dependency index we were in was 0. So that's what the current dependency index was set to when fetch was executed. And the failure reason that's being reported here is 404. I guess it didn't find the manifest when it went looking for it at that URI. So that's how you get through a suit report record and what it means through each section. And that's all there is to it. So any questions on suit records?
So in this example, the thing that it couldn't find, was it the TA binary manifest, or was it the actual config.json file? Because both of the config.json file was the one that said that in your example, you're going to resolve that via an HTTPS URI. So which thing actually failed here?
So this was, and I realize this is slightly broken compared to the assumptions we laid out in the previous one, that both were delivered via a TEEP update message. Well, in this case, it wasn't delivered via the TEEP update message, or it was corrupted, or something was wrong with it, because when it went looking for it, it couldn't find it. It's done a fetch. Fetch has tried to find it and hasn't located it. And in this case, it is. You can see that it's got that same UUID. For the name, but it's got a .suit extension, and that is its manifest.
Okay, so for the example that we'd want to put into the document, I think we'd want it to match, and we'd probably want to show the case where the dependency resolution of the actual HTTPS URI to grab the config.data was what failed.
Yeah,
say it was
fair enough.
server unreachable or something like that, and you got a 404 from that URL or whatever it was. So,
Yep, that absolutely fine. Yeah.
okay. All right. So noted that I won't take this example literally. I'll need to get a slightly updated example from you that shows the other case to put it into the document. But all right, thanks.
Was that it, Brendan?
Yeah, that's it. I'm done. There's
Cool.
It's all over. There isn't any more.
Well, and Dave, I think you have your guidance then for the example, right? Given your last comment.
Yeah, right. I guess Brennan has a couple of action items there. One is there's that bug in the encoding of RPMB.
Yeah,
which
I'm really not sure on that one.
Yeah. And then you said like the image size was missing from the slide, and so we need the example that shows that. And then the one that shows the dependency resolution of a different URL. But otherwise, I think the manifests are directly usable as is, and the suite reports will need those particular tweaks. So, But other than that, I think these are great examples. Again, thanks, Brennan, for putting these together for us.
Indeed.
You bet. And I'm sorry that I don't have another half hour for of manifest content for you, Ben.
Surely you jest. All right, so I think with that, we are done with the agenda. Dave, I think your next steps is you've gotten feedback. You can turn another revision for the draft. With that, I will ask if there's any other business. Going once, going twice. If not, we can give you some time back. Oh, Akira, did you have a comment? You're sharing video, I think. We can't hear you, Akira.
Yeah. I just wanted to show my face at least once. That's all. Olympic here.
I love the hat. It's awesome. All right. So with that, I give you guys good wishes for a good weekend, and we'll look forward to our next session. Thank you, everyone. Good progress, Dave, Ming, Hannes, Akira.
Thanks a lot.
Thank you.
Thank
Have a
you.
good weekend.
All right. Bye, everyone.